When the going gets tough, the tough gets going. In this video, we'll cover certain key 3 marker, 4 marker, and 5 marker problems. Again, just practice these problems. You can focus on parametric differentiation, right? And then you have problems on logarithmic differentiation. This is important. And infinite series, very easy. Implicit function, this is also easy. There is a playlist on differential calculus where all the subtopics of differential calculus such as logarithmic differentiation, implicit functions, parametric functions, infinite series, double differentiation, all of these are explained. So if you want to understand concepts in detail, you can go through the differential calculus playlist. Also, there is a video on important questions for 1 markers and MCQs. Let's go through the problems. Parametric function means you have 3 terms. You have x, you have theta, you have y, you have theta. So you have 3 different parameters, right? So that's why it's called parametric. You're trying to find dy by dx, but you have theta here as the term. So what I will do, I'll first differentiate x expression with x. So dx by d theta I'll get. Then I'll differentiate y with respect to theta, dy by theta I'll get. If I have to find dy by dx, I need to take dy by d theta divided by dx by d theta. Then what's actually going to happen is d theta will get cancelled. So I'll get dy by dx. So I'll take derivative of dy by d theta as sine theta, cos theta, I'll divide that. I'll get dy by dx. Parametric function is very easy, right? Focus on this. Find dx by dt, dy by dt. Then take both these expressions and divide, right? And you'll get dy by dx. Here also similar thing. Dx by dt you find out, dy by dt. Then divide both and find the value. Now, when you have something like this, differentiate tan root x with respect to x. What you have to assume is, this is one expression, this is one expression. So assume that y is equal to tan root x and t is equal to root x. You can also assume that this is u and this is v, whatever. You name it the way you want. So you have two functions here, u and v. You have to differentiate this one with respect to this one. Now, when I say with respect to root x, that means this should be in the denominator. This should be the denominator function. So it should be tan root x. You're differentiating like this, tan root x with respect to root x. Right? Now what is tan root x? I've considered as y. So dy. What is root x? I've considered as t. So it is dy by dt. Now, so I'll differentiate this separately. When I differentiate this, I differentiate with respect to x. Whatever is here, I'll differentiate with respect to that particular variable. So I have x here, so differentiate with respect to x. Here also I have x, so I'll differentiate with respect to x. Divide both of them, I'll get this. Next one, differentiate tan square x with respect to cos square x. Again, assume that u is tan square x, v is cos square x. You have to find du by dv. That is, this should be the numerator function. This should be denominator function because it's with respect to cos square x. With respect to cos square x means this is denominator. And what is denominator? V. So dv. Differentiate this u function, v function, divide it, and you'll get the answer. Sixth one, same thing. How do you know if it's parametric? You will see two functions and third parameter. You will see 3 parameters, x, y, and something else like theta or t or something. So when you notice there are 3 parameters, use parametric function. This is another one, right? Same approach. Here, this is logarithmic problem, right? So now, how will I solve? Whenever I have powers, what is the clue? How do I know when I have to apply log? Simple. If you have a variable as power, in the power, if you have variable like x, y, z, then you have to use logarithm. Or if you have trigonometric function, if x to the power sin x, x to the power tan x, then I have to use log. So once I apply log, there is log property, right? Right? If I have something like this, if I apply log, it will become y log x. Log m to the power n is n log m, using this log property. So I'll get this. Log e. Remember this? Log e, value of log e is 1. So I'll get y minus x. Take y to the other side. When I take y to the other side, I'm left with x here. Right? Then I'll find only value of y. Y is equal to this much. Now I'll differentiate because I have to find dy by dx, right, ultimately. So I'll differentiate, I'll get dy by dx and solve this. You have to prove that this right hand side expression is true. Next one. Okay, here again you have logarithmic. Sin x to the power tan x. Simple. What you will do? Apply log. So you'll get tan x into log of sin x. Tan x will become the power, right? So it will come here. Tan x. into log of sin x, log y. Differentiate. Infinite series. This is again very simple. Infinite series is the simplest one in differential calculus. Simple, right? You assume that y is equal to, you put the square root as is, put sin x, first term you put, then remaining else will be y. This remaining everything should be y. So it will be sin x plus y, right? Now I'll find derivative. Once I find the derivative, I get dy by dx is here. So I'll get this right hand side. This problem is a little lengthy, but it is simple. This is another infinite series problem, right? Take the first term, e to the power x, then remaining everything else is y. That's all. Take the first term out and then add it up with y, like this. Here you have to add it to the power. Remember, don't make it like this. No, this is wrong. So it should be, first term is e to the power x, right? And how actually it is like this: x to the power e to the power x, again x to the power e to the power x, again x. This is how the series is. It goes like this. So how I should remember this? I'll take the first term out, which is e to the power x, right? Now what is this entire thing? It's to the power only, right? It's to the power. So I should make it, add it with what? What is this entire thing? Y only, right? So it will be like this, to the power. Right? Now I apply log. Why? Because it's to the power. There is power. There are two variables in the power. So I apply log. And log e is 1. That's all. Right? You differentiate. So I'll get log y minus y is equal to x. So what I'll do, I'll differentiate. Then rearrange the terms. And you'll get this expression. So last problem. Find dy by dx. This is an implicit function. Implicit function is nothing but you have x and y mixed up. Right? See here, x and y is mixed up. So it's called as an implicit function. But it doesn't matter when we solve whether it's implicit or not. What we will do here is log xy. So this is of the form like this. Log xy can be written as log x plus log y based on logarithmic law. So I'll split this like this. Now I'll differentiate on both sides. So get all the dy dx terms on one side and the x terms on the other side. And then you will find dy by dx. All the x terms on one side and dy by dx on the other side. We'll look at next problem. If x is equal to a theta, y is equal to a by theta, then prove that dy by dx plus y by x is equal to 0. So basically this is nothing but parametric differentiation. This, how do you understand if it's parametric differentiation or not? Now here you have x given in terms of theta, y given in terms of theta, but you have to find dy with respect to dx, right? You have to differentiate y with respect to x, but here you have in form of theta. That's why it becomes parametric. So you have three parameters here. One is y, one is x, and theta. Three parameters are there. That's why it's called as parametric. Now, so what you should do is, to find dy by dx, you have to find dy by d theta, right? And then you have to find dx by d theta. Then divide both, right? Your dy by dx will be nothing but, it will be dy by d theta by dx by d theta. D theta and d theta will get cancelled. Then you will get dy by dx. So now you first find dy by d theta. So differentiate this particular expression with respect to theta. So it's 1 by theta. Derivative of 1 by theta is minus 1 by theta square. And a, you leave a as is. Similarly, you find dx by d theta. So you differentiate this. Derivative of theta is 1. Derivative of theta is 1. So you are left with a. Now you have to find dy by dx. So you take dy by d theta divided by dx by d theta. Simplify, you will get minus 1 by theta square. You will get minus 1 by theta square. Now you have to prove that dy by dx plus y by x is equal to 0. So you have got dy by dx. You have to find y by x. Y is a by theta. X is a into theta. Divide this, you will get 1 by theta square. Now you have to take this expression dy by dx plus y by x. What is dy by dx? Minus 1 by theta square. What is y by x? 1 by theta square. Right? When you add, it's going to become 0. Right? Minus 1 plus 1 is going to become 0. Therefore, it's proved. Now, 14th example. Again, this is parametric because x is in terms of theta, y also in terms of theta, and you have to find dy with respect to dx. So, first find dx by d theta. right? Derivative of this is 1 minus cos theta. Then you find derivative of dy with respect to d theta, derivative of y function. So you'll get sine theta. Now you, to find dy by dx, take dy by d theta, divide by dx by d theta, right? Dy by d theta by dx by d theta. So nothing but sine theta by 1 minus cos theta. Look at 15th problem. Similar, again this is also parametric, right? This is with respect to theta, this is also with respect to theta, and you have to find dy by dx. So first find dx by d theta. So you'll get a secant theta into tan theta. Find dy by d theta. So derivative of tan theta is secant square theta, right? And now you find dy by dx, which is dy by d theta by dx by d theta. So your dy by d theta is b secant square theta. Dx by d theta. What is derivative of secant theta? It is secant theta into tan theta, right? So now when you simplify, you will get this kind of an expression. Now you'll have to find dy by dx at theta is equal to pi by 4. So substitute this theta with pi by 4. Is substituting theta with pi by 4. So sine pi by 4 is sine 45. Sine 45 is 1 by root 2, which is nothing but root 2 b by a. Now here, this is an example of an infinite series. You can assume y is equal to root x. Take the first expression. First expression is root x. Take that out. Then plus, what is this? What is this remaining expression? Y itself, right? What is y? Root x plus root x to the infinity. So here you have x. This entire thing is y. And then you have x left. You're taking the first term, which is x, right? And then entire thing with the root on top. So you write that like that, then square on both sides so that you can eliminate square root. If I square root, it's going to become like this. Square and square root will get cancelled. So you'll get y square is equal to x plus y. Now you differentiate, right? Bring all dy by dx to one side and shift everything else to the other side. You will get this particular answer. Now let's look at problems related to double differentiation or second order derivative, right? These are basically 5 markers and 4 markers. So we'll look at a few problems related to this. Now you can practice all of these problems, right? You can practice all of these problems. These are just practice questions, right? Practice questions so that you can be confident that you are aware of this particular topic or concept. So first one, if y is equal to this particular expression to the power m, so that this particular expression is equal to 0. Now you will have to use double differentiation. Now, how do you know that it is double differentiation? Because you have y2 here, right? This y2 subscript, this y2 will tell you it's second order derivative or double differentiation. If you have y1, then it becomes first order derivative. That is first differentiation. If you get y2, then it is second order derivative. So we have y is equal to x plus root of x square plus 1 to the power m. Now what we will do is we'll differentiate this with respect to x. So when you differentiate, you're going to get dy by dx. Since everything is in terms of y1 and y2, we'll tell this as y1 is equal to, now here you have power. So whenever you have power, first find the derivative of power, right? Now you know that there is a theorem, x to the power, derivative of x to the power n is equal to n into x to the power n minus 1. So we'll use, now instead of n we have m here. So we'll say m into, instead of x we have this entire expression. We'll copy it as is and this will become m minus 1. Now we will use the chain rule, right? We'll have to use chain rule because there are terms inside, right? For all these terms we have to find derivative. So first is x. So what is derivative of x? Remember, when you're putting chain rule, you have to multiply. You have to multiply to continue. Now here you have x. So you multiply, open the brackets, derivative of x is 1. Derivative root of x square plus 1. Whenever you have root, the derivative would be 1 by 2 root. Whatever is there inside, you copy like this. So here it will be 1 by 2 root x square plus 1. Now you have finished these two terms. But now again you see inside there are terms here, right? Now that means you're continuing the chain here. When you're continuing the chain, again you have to put multiplication. What is derivative of x square? 2x. And derivative of 1 is 0. So we're not writing it. So now 2 and 2 will get cancelled. So let's see. Let's write this. You'll get root of x square plus 1 to the power m minus 1. You'll get 1 plus x by root of x square plus 1. Now we'll take the LCM here, right? We'll take the LCM for this portion. So we'll get, I'll just copy this as is. So if I take LCM, LCM would be root of x square plus 1. And here there is 1. You have to get LCM. You have to multiply with some number so that you get this LCM back. So what should I multiply 1 with? You should multiply with this root x square plus 1. Only then you're going to get this LCM. So but I have to multiply the numerator with root of x square plus 1. So 1 into root of x square plus 1 is root of x square plus 1. And then here you have the LCM itself. The denominator is same as LCM. So you don't have to multiply anything. So you just copy this numerator as is. Now if you notice this expression and this entire expression, it's same, right? It's same. But you assume that the power is 1 here. This is power is 1. So when the bases are same, you see the bases are same. It's the same term. You need to add the powers. So you can add this 1 here. This 1 and 1 will get cancelled. You're left with m. So you'll get m into x plus root of x square plus 1 to the power m into root of x square plus 1. And here we have y1. Now whenever you have denominator term, try to shift it to the other side so that it becomes multiplication. So this will become y1 into root of x square plus 1. And then you copy the remaining things. This is nothing but first order derivative. This is first order derivative. Now we'll have to differentiate again, right? Because we need to find y2. We have to find second order derivative. So differentiate again with respect to x. So now you'll differentiate this. Now you see there are two terms here, first term and second term. So you have to apply product rule. Whenever there are two terms or multiple terms, you have to apply product rule, because here there is multiplication, right? There is multiplication. So product rule states that first function into derivative of second function, which is root of x square plus 1, plus second function, which is root of x square plus 1, into derivative of first function. What is first function? y1. So this is first function and this is second function. This is equal to, let's not forget this, this is equal to m into x plus root of x square plus 1 to the power m. What is y here? X plus root of x square plus 1 to the power m. Can we substitute this entire expression as y? Right? We can. So we can, instead of this entire expression, we can write it as m into y. We have to differentiate this entire thing. So this will be d by dx. What is derivative of root of x square plus 1? 2 root. Just replace the same thing with 2 root. And now we'll have to start the chain rule because you have terms inside. Derivative of x square is 2x. Derivative of 1 is 0. So we leave it like that. We'll go to the next one. Root of x square plus 1. Derivative of y1 is y2. And m we leave as is. Derivative of y is y1. 2 and 2 will get cancelled. Now we'll take LCM here. So we'll get root of x square plus 1 as LCM. So this will be y1 into x. This will have to be multiplied with root of x square plus 1. Only then we'll get this LCM. You have to multiply the numerator with x square plus 1. So I'll get root of x square plus 1 into root of x square plus 1 into y2. And this is m y1. Now, so this becomes square. X square plus 1 into x square plus 1 becomes square. Square root and square will get cancelled. So I'll get xy1 plus x square plus 1 into y is equal to my1. And I'll shift this here. So I'll be into root of x square plus 1. So let's look at the original expression. Let's see what terms we have in common. This is the original expression. So we have x square plus 1 y2 as common. We have xy1. We need my, but we have this entire expression. So now we need y here. So let's see what we can substitute. What is y here? Let's go back to see if there is first derivative. What is the first derivative? Here, this one. we'll have to use this first order derivative here. This is actually y1 into root of x square plus 1 m. This entire thing can be y, right? We substituted. This entire thing is nothing but y. We'll substitute y here, right? This is actually the first order derivative. So we have y1 into root of x square plus 1 as my. So this will become my. So now what is it? Nothing but m square y, right? Now I shift this here. So I'll get this final expression. Now let's look at the second problem. Fairly simple. Differentiate this expression with respect to x. So here you'll have to use quotient rule because there is division here. What does quotient rule say? Quotient rule will say denominator, right, which is denominator into derivative of numerator minus numerator into derivative of denominator by denominator the whole square. Now what is denominator here? E to the power x plus 1 into derivative of numerator is e to the power x minus 1 minus numerator, which is e to the power x minus 1 into derivative of denominator, which is e to the power x plus 1 upon e to the power x plus 1 the whole square. So this is nothing but e to the power x plus 1. What is derivative of e to the power x? E to the power x itself. Derivative of 1 is 0. Similarly, you copy this as is. What is derivative of e to the power x? E to the power x itself. Derivative of 1 is 0. And put the denominator as is. So this entire expression is the derivative. Now let's look at the third problem. If y is equal to log of this entire expression, show that this expression is equal to 0. Again, you have to use double differentiation because you have y2 here, right? So we'll use this. We'll try this out. So we have y1, y2. So we'll put differentiate first. So we'll get y1. Log of this entire thing. Log of a function, derivative of log of a function is 1 by x. Instead of x, we have this entire term. We copy it as is. Now we'll continue with chain rule, right? Because we have terms inside. Now open the bracket, multiply, open the bracket. Instead of derivative of x is 1. Then you have plus here, copy it as is. Then what is derivative of root of x square plus 1? It's 1 by 2 root of x square plus 1. Then again you have to continue the chain rule. This is a separate term now. So when you're starting a new chain rule, again put multiplication. And what is derivative of x square? 2x. What is derivative of 1? 0. So we leave it like this. So now 2 and 2 will get cancelled. So we'll get y1 is equal to 1 by x plus root of x square plus 1 into, we'll take LCM here, right? LCM will be root of x square plus 1. You will multiply this with root of x square plus 1. Only when you multiply 1 with root of x square plus 1, you will get this LCM. So, but I multiply the numerator. So, I'll get root of x square plus 1. Here, I already have the LCM itself, so I don't have to multiply. Just copy this as is. You notice that this term and this term will get cancelled. You'll be left with 1 by root of x square plus 1. Whenever you have denominator term, shift it to the other side. So, you'll get y1 into root of x square plus 1 is equal to 1. Next, you again differentiate. So, this is your first order derivative. Just mark this. This is your first order derivative. Now, you differentiate again. You have to apply product rule because there are two terms here. This is first function. This is second function. So, as per product rule, first function into derivative of second function plus second function into derivative of first function is equal to 1. What is derivative of 1? 0. What is derivative of root of x square plus 1? 1 by 2 root of x square plus 1. Now chain rule starts. Start multiplication, put the bracket open. Derivative of x square is 2x. Derivative of 1 is 0, so we ignore. Plus root of x square plus 1. Derivative of y1 is y2. Right? Now 2 and 2 will get cancelled. So we'll get xy1 by root of x square plus 1 plus root of x square plus 1 into y2 is equal to 0. Now let's find LCM here, right? So LCM would be root of x square plus 1. You don't have to multiply anything here because you already have the LCM term. Here you have to multiply. You assume that there is 1. Only if you multiply this 1 with this LCM, you will get the LCM back. So you have to multiply the numerator with x square plus 1. So I'll get root of x square plus 1 into root of x square plus 1 is nothing but x square plus 1 itself and y2. This is equal to 0. So when I shift this here, this will become 0. So I'll be left with xy1 plus x square plus 1 into y2 is equal to 0. What is our original expression? X square plus 1 y2 plus xy1. X square plus 1 y2 plus xy1. So we got the expression. So we have proven this second order derivative. Now let's look at next problem. Y is equal to e to the power x into log x. Now you differentiate. You have to use product rule here, right? It's nothing but e to the power x into derivative of log x plus log x into derivative of first function, which is e to the power x. So e to the power x, derivative of log x is 1 by x. Log x you have, derivative of e to the power x is e to the power x itself. And then you can substitute. You have e to the power x into log x here, which is nothing but same as y. You substitute y here, then take the LCM, right? And then take x to this side. So you'll get xy1 is equal to this expression. Nothing should be in the denominator when you take the second order derivative. Shift it to the other side. So you differentiate again, right? So again here you'll use product rule, right? So you have xy1. So product rule means x into derivative of y1 plus y1 into derivative of x. So this will be x, derivative of y1 is y2, y1 into derivative of x is 1. So you'll get this particular expression here. Then you have to differentiate this side also. Derivative of e to the power x is e to the power x. Derivative of xy. Again you have to use product rule. You'll get this expression, right? Then rearrange the terms, right? Remember these. You have to get terms similar to this, right? Simplify and rearrange, and then you can prove this particular expression. Next one. So find the derivative. So here you'll get the first order derivative. Let's find the second order. Let's do this. So first order was y1 into root of x square minus 1 is equal to y. Now let's differentiate again. So you'll have to use product rule. Y1 into derivative of second function, which is root of x square minus 1 plus root of x square minus 1 into derivative of y1 and derivative of y. So this will become y1. Derivative of root of x square minus 1 is root of 2 root of x square minus 1. Use chain rule. X square becomes 2x. Minus 1 is 0. Derivative of minus 1 is 0. We'll go to the next one. Root of x square minus 1. Derivative of y1 is y2. Derivative of dy by dx is nothing but you can write as y1. So here 2 and 2 will get cancelled. So you'll be left with xy1 by root of x square minus 1 plus root of x square minus 1 into y2 is equal to y1. Now we'll take LCM. LCM would be root of x square minus 1. So this will go once and this will go. You have to get, the denominator is nothing, you assume it as 1. You have to multiply 1 with this to get this as the LCM. You have to multiply 1 with this to get this as the LCM. But you have to multiply the numerator, right? Here you have to multiply. So this will be xy1 plus, you have to multiply root of x square minus 1 with this term. And then you have y2 also. So here square root and square will get cancelled. You'll be left with xy1 plus x square minus 1 into y2. Now I'll shift this here. So this will be y1 into root of x square minus 1. Now let's see what our original expression is. So this is our original expression. We have got x square minus 1 by 2. We have got xy1. We need to get this one. This expression we need to get. Now let's see if there's anything that we can substitute for y. What is y here? Y is this part, right? Y is this first order derivative. We can substitute y1 into root of x square minus 1 is y. Here we have y1 into root of x square minus 1 as y. So we'll substitute, right? So we got the expression. Now shift this here. So you'll get xy1 plus x square minus 1 y2 minus y is equal to 0. So we got the expression. Now we look at this problem. Again, this is infinite series problem, right? This is 3 marker. We'll just go through this. So for infinite series, let us try to solve this. So we assume that this particular expression is equal to y. Now what we will do, we'll take the first term out, right? We'll take the first term out. First term is root x. And then the remaining terms, if you notice, this term is also y only, right? It's infinite term. You took first term out, which is root x. This entire thing is also y itself, right? What is y? Root x plus root x plus root x. It goes on till infinity terms. So you can write here root of x plus y. So now I'll differentiate, right? I'll differentiate with respect to x. So I'll get dy by dx. So instead of dy by dx, I'll write y1. Root of x plus, derivative of root of x plus y is equal to 2 root of x plus y. Then what is derivative of x? It's 1. What is derivative of y? It is dy by dx, which is y1. Okay, here you have to remember it's in the form of dy by dx itself. So we don't have to put y1. Let's put it as dy by dx itself. Right? If y1 is given, put y1, or else we put dy by dx. Now you watch this carefully. What is this? What is root of x plus y? Root of x plus y is nothing but y. That's what we assumed, right? Root of x plus y is y. So we'll substitute. We'll write this as 1 by 2y into 1 plus dy by dx. So I'll shift 2y here. So whenever I have denominator, shift it to the other side. So it will be 2y into dy by dx is equal to 1 plus dy by dx. Now if I bring this here, this will become 2y dy by dx minus dy by dx is equal to 1. Now I'll take dy by dx as common, right? So I'll get dy by dx as common. I'll be left with 2y. Here it will be minus 1 is equal to 1. Now I need to find dy by dx only. So it'll be 1 by, I'll shift this here. So it'll be 1 by 2y minus 1. Let's see what's the expression. Okay, we got the expression. So this is the answer. Now let's look at next problem. If y is equal to this expression, so that this expression is equal to 0. Now again, we can try this out. Let's work it out. It's a lengthy problem. Let's work it out. So we'll first differentiate. So we'll get dy by dx. Let's see, is it in terms of y1 or y2? Okay, it's in terms of y1, y2. Okay, so instead of dy by dx, we'll put it as y1. We'll use a theorem. This is x to the power n. So it'll be n into x to the power n minus 1. Instead of x, we have this entire long expression, n minus 1. Now we'll use a chain rule. That is, you have to put multiplication here. What is the derivative of x? 1. What is derivative of root of a square plus x square? Derivative of root is 2 root a square plus x square. Now again, when you're putting chain rule, you have to put a multiplication here. Derivative of a square is 0. Derivative of x square is 2x. Now 2 and 2 will get cancelled. I'll take LCM here. So first let me write this. So when I take LCM would be root of a square plus x square, right? This has to be multiplied with root of a square plus x square to get this particular LCM. You have to multiply numerator with this. So I'll get 1 into, it will be root of a square plus x square plus, here I have to multiply with 1 to get this as LCM. So 1, and then I have x here. If you notice this and this, it's same, right? This portion is same. So this is, here assume that power is 1. You add this here, right? Because the base is same. When base is same, you can add the indices. So here minus 1 will get cancelled. You will get n into x plus root of a square plus x square to the power n by a square plus x square. Root of this is y1. Now I can shift this here. So I'll get y1 into root of a square plus x square is equal to n into x plus root of a square plus x square to the power n. Now what is this entire expression? It's y, is it not? This entire expression is equal to y. So let's put it as y. This is nothing but n into y. Right, now I have to differentiate again. Right, if I differentiate again, this will become, I have to use product rule. Differentiate again, y1 into derivative of root of a square plus x square. I'm using product rule, plus root of a square plus x square into derivative of first function, which is y1. And here n into derivative of y is y1. Now, what is derivative of root of a square plus x square? 1 by 2 root of a square plus x square. derivative of x square is 2x plus root of a square plus x square. Derivative of y1 is y2 into ny1. Now we'll take the LCM between both of these. So it will be y1 into x by root of a square plus x square, right? Now while LCM would be a square plus x square. So this has to be multiplied with a square plus x square, right? So it will be root of a square plus x square. Have to multiply this, and you have y2 is equal to ny1. So a square and square will get cancelled. So we'll get xy1 plus a square plus x square into y2 root of a square plus x square is equal to ny1. Now let's see how we should get the expression. We have to prove this. Let's see what are the common terms we have got. This is the expression. Okay, we got a square plus x square and y2. We have xy1. We have to get n square y. So we'll shift this here. So I'll get xy1 plus a square plus x square into y2 is equal to ny1 into root of a square plus x square. So I should get y here. That means this portion has to be substituted. Let's see. Okay, here y1 into a square plus x square is ny. So y1 into a square plus x square is equal to ny. So n into ny, which is nothing but n square y, right? Now I rearrange these terms, right? This is what I will get. So when I bring it here, it will become xy1 plus a square plus x square y2 minus n square y is equal to 0. So I have proved this statement. Now next one, if y is equal to a cos of log x plus b sine of log x, prove that this expression. Here again, so differentiate first time. So here dy by dx is equal to, we'll find the derivative. Derivative of cos is minus sine and derivative of log x is 1 by x. So here we are using chain rule. And then here derivative of sine is cos, derivative of log x is 1 by x. Now you shift this x because 1 by x is common, right? You will actually get it like this, right? 1 by x is common. So you will get minus a sine of log x plus b cos log x. 1 by x is common. You will shift x this side. So you will get x into y1, right? Now you differentiate again, right? Use product rule here. y1 into derivative of second function, which is x, plus second function, which is x, into derivative of first function. This is the first function. And then derivative of cos is minus sine, derivative of sine is cos, right? Again you take 1 by x as common, you will get this expression. Now you notice what is this expression? It's nothing but y, right? This entire expression is nothing but y. So substitute y here. Substitute y here and shift x to this side, right? Like this. Now you expand it and you will get this entire final statement. Now again we'll go through this. Again this is parametric. Find dy by dx if x is equal to e to the power 2t and y is equal to log 2t plus 1. How do I say it's parametric? Because this is in the form of t, x is expressed in the form of t, and here also y is expressed in the form of t. First find dy by dt. This is y function. Log of 2t plus 1 is 1 by 2t plus 1. Chain rule. What is derivative of 2t? 2. Then similarly dx by dt. Derivative of e to the power 2t is nothing but e to the power 2t, right? So first you'll have to find the derivative. Assume that it is e to the power x. What is derivative of e to the power x? E to the power x itself. But instead of x we have 2t, right? We put 2t as is. Then we find the derivative of 2t. What is derivative of 2t? 2. Now you find dy by dx, which is nothing but dy by dt by dx by dt. Dt and dt will get cancelled, so we'll get dy by dx. What is dy by dt? 2 by 2t plus 1. And what is dx by dt? 2 into e to the power 2t, right? And simplify, you will get the final expression. Now 10th one, differentiate with respect to x, right? Apply here, whenever you have powers here, right? Try to apply log. if you apply log, you can get rid of these powers. So when I apply log on both sides, this will become log y, and this will become applying log on this. So when log of a to the power m is nothing but m log a. So we have log of x plus 1 the whole square here. So you can write this as 2 log x plus 1, right? So 2 log x plus 1. Similarly, I have log of x plus 2 the whole cube. So you can write it as 3 log of x plus 2. And then you have log x plus 3 to the power 4. You can write this 4 log x plus 3. I can write it like this. Now since there is multiplication here, since there is multiplication, when you apply logarithms, it will become plus. Multiplication will get converted to addition. So now your multiplication has become addition. Now you can differentiate, right? Now you can differentiate. So you have got rid of the powers, and now instead of multiplication, you have addition. So it becomes easy to find derivative. So what is derivative of log y? 1 by y. And you have to put dy by dx here, because derivative of y is nothing but dy by dx. And what is derivative of 2 log of x plus 1? Derivative of log x is 1 by x. Similar derivative of log x plus 1, instead of x, you put x plus 1. That's all. So 2 by x plus 1. Here it will be 3 by log of x plus 2 is 1 by x plus 2. 4 by x plus 3. Log of x plus 3 is 1 by x plus 3. Right? And then you shift y this side. So you get y into this entire expression. What is y? Substitute this. Y is this one. So I'm substituting this entire thing, and then you're getting the derivative finally. Now this is again infinite series problem. Right? So you assume that you take the first term, right, e to the power x, and then what is the remaining terms? This is nothing but e to the power x to the power e to the power x, right? Remaining term is also y. So it will be e to the power x into y. Right? Now I apply log because you want to get rid of the powers. So you apply log. So it will be log y is equal to log e to the power xy. Now, what is the logarithmic rule? If you have log e to the power m, you can write as m log a. So you have power as xy. So you can write as xy log e. You take the power, put the power here, and you can write as log e. Log e is 1. Okay, log e is equal to 1. So you put 1 here. So xy into 1, right? You get xy. So log y is xy. Log y is xy. Now you differentiate. So log y is 1 by y. Derivative of log y is 1 by y. Dy by dx. Then x into, you have to use product rule here. What is it? Product rule, x into derivative of y, second function, plus y into derivative of x. So this is nothing but x into dy by dx plus y into, this is x. What is derivative of x? It's 1, right? So y into 1. Now you simplify, right? You get the dy by dx terms together. So when you shift this side, it will become minus x dy by dx. Take dy by dx as common. So I'll be left with 1 by y minus x. Right? Now you take this LCM here. So y 1 minus xy. Now you only have to find dy by dx. Shift everything to the other side. So it will be y by separate. It will become reciprocal when you shift this. So y by 1 minus xy. So it will be y square by 1 minus xy. Now this is again another infinite series problem. Again, you first assume that split this, take this first term sin x, and this entire thing is y, sin x to the power y. Apply log. So it will be y log sin x. Differentiate. Derivative of log x is 1 by x. Instead of x, I have sin x. Derivative of sin x is cos x. Use the chain rule. Similarly here, you have to use product rule here because you have two terms, y and log of sin x. So you're putting product rule. So log of sin x into derivative of first function, which is dy by dx. Right? Now what is cos x by sin x? Cot x. Because here you have to get cot x. Right? In this proving statement, you have to get cot x. So cos x by sin x is cot x. And shift this y to the other side. So I'll get dy by dx. I'm shifting y to the other side. So y into y by y cot x plus log of sin x into dy by dx. So y into y is y square cot x. So this will become y log of sin x into dy by dx. And now let's look at the original expression. I should get cot x y log of sin x. So I'll bring this dy by dx together. So it will be dy by dx. When I shift this here, it will become minus y log of sin x into dy by dx is equal to y square cot x. Now I'll take dy by dx as common. So I'll get dy by dx is equal to 1 minus y log of sin x is equal to y square cot x. Now I just need to find dy by dx, right? So I'll shift this entire term here. So it will be y square cot x divided by 1 minus y log of sin x. Did I get the expression? Y square cot x by 1 minus y log sin x. Yeah, I got it. So therefore I've proven the dy by dx. So let's look at the last problem. Differentiate x cube into e to the power 2x into secant square x with respect to x. Now you assume that this entire expression is y. Now you have to apply log y because you have powers here. You want to get rid of the powers. So apply log. So it will become log y. Log of x cube will become 3 log x. Log of e to the power 2x will become 2x log e. And secant square x, log of secant square x is 2 log secant x. Now log e is equal to 1. So instead of log you can put 1. So you'll be left only with 2x. Now I'll separately differentiate. So log of y is 1 by y into dy by dx. And log of x is 1 by x. And derivative of 2x is 2 here. Derivative of log is 1 by x. Instead of x I have secant x. What is the derivative of secant x? It is nothing but secant x into tan x. Now secant x and secant x will get cancelled. So I'll be left with 2 tan x. Right? Now I shift this y here. I had y here. I shifted here. So this is in division. It became multiplication. Now what is y? Y is nothing but this entire expression. So instead of y, put this entire expression and you get the derivative. So with this, we've come to the end of this particular video. If you have liked this video, do press a like and share it. Thank you.